Okay, let's talk about reactions of alkyl halides. In general, there's two categories of reactions that can happen. There's substitution, like this one shown here, where a bromine is substituting with the hydroxide ion. And there's elimination. And that's where the bromine and an adjacent hydrogen are eliminated to form an alkene. Okay, so what's going on here? Well, in the first case, the lone pair on the hydroxide ion is directly attacking the carbon with the positive charge. Right? The halide bromine is more electronegative than carbon. Carbon's positive. That attracts these electrons, which are negatively charged. And the lone pair is attacking as a nucleophile. It's going after that positive center on the carbon. And in the second case, the lone pair on hydroxide ion is actually going after the adjacent hydrogen, and it's acting as an H plus acceptor. It removes a hydrogen, a proton, leaving behind the electrons. It's removing H plus. It's acting as a base. And that's the difference. When the lone pair on the nucleophile attacks directly, we get substitution. And when the lone pair acts as a base, well, then you get elimination and a carbon-carbon double bond. These two classes of reactions, substitution and elimination, well, they can go through a total of 5 mechanisms. There's 2 substitution mechanisms. They're very similar, slightly different. We're going to become familiar with both of them. They're called SN1 and SN2. The little 1 stands for unimolecular, meaning there's one molecule in the rate determining step. And then there's a 2 here if it's bimolecular, 2 molecules in the rate determining step. Sometimes it's also called second order because of the kinetics. The rates of reaction, the kinetics, is second order. And there's 3 elimination mechanisms, and again we have first order, second order, or unimolecular, bimolecular. And then there's a special one. It's a first order reaction involving a conjugate base. It's kind of a special case, but it's thrown in the mix here too. So we'll become familiar with these 5 mechanisms, and after we understand these, this is going to help us predict products for these alkyl halide reactions. And so finally, I just got some helpful facts we want to keep in mind. Some are more helpful than others. The first one's really good for the substitution reactions. Just find the nucleophile and trade places with the halide, and then you got the product. Secondly, if you have any of the elimination mechanisms, well, you got alkenes or alkynes as the products. And then when we have to write out the mechanisms, it's good to know that the ones with the 2s, SN2, E2, they usually only have a single step in the mechanism. Nice and sweet. And then the other thing we have to keep in mind that the 2s often occur at the same time. Sometimes. And then when they occur, well, we're going to have to give products for both of those mechanisms. And then the 1s, SN1 and the E1, have usually 3 steps in their mechanisms. And they too, more often than not, occur at the same time. They both SN1 and E1, have carbocation intermediates. So darn it, we have to watch out for rearrangements. You know, the hydride shift or the alkyl shift. So watch out for those. And then finally, the last case, it really is an outlier. The E1CB with that conjugate base. Here's the crazy thing we have to keep in mind. It doesn't work on alkyl halides. So you're probably wondering, well, why is it even here? This is a unit on alkyl halide reactions. Well, the reason why is the author of your textbook said, hey, it produces alkenes just like the E1 and E2 mechanisms, so we should include it in here as a very similar mechanism. And then finally, the E1CB is just more common in biological systems. And it's different from all the other 4 in that it has a carbon with a negative charge. So we'll learn about these 5 mechanisms, but I think it'll be helpful just at the get-go to give a feel for these types of mechanisms and start getting used to these 5 terms, these abbreviations over here. And then finally just realize that the simplest part, it's really a matter of deciding whether you're getting substitution or elimination. These two groups just going away and you get a double bond.